Our notes are on 2.7, arithmetic sequences. So the first thing I want to write down is an example of what an arithmetic sequence looks like. Okay? Let me write this down, and feel free to write this example if it looks very similar to number 1. 15, 11, 7, 3, -1, ... And what we're going to do with this arithmetic sequence, 15, 11, 7, 3, -1, ... These are ellipses. It means the pattern continues, in case you wondered. Okay? And the directions are going to say, describe the pattern, then find the next two terms. Describe the pattern, then find the next two terms. What I'm hoping you know. Describe the pattern, then find the next two terms. If it's a sequence of numbers, something is happening to go from 15 to 11, from 11 to 7, from 7 to 3, from 3 to -1. Do you know what's happening? If you know, tell the person you're sitting next to, go ahead and discuss it real quick. So let me check for understanding. Let me call on one of you who's not expecting it. Natalie is not expecting it. Natalie, what is happening? It is subtracting by 4. That's what she says. Is this enough for our to describe the pattern? Almost. This is half of what I want. You need to tell me how they're finding the next number. Subtracting by 4, and it starts with what number?
15.
It starts with 15. The two things that I'm going to want you to describe the pattern with. What is happening? What is the change? Let's put down the change right below this. And then what it starts with. And what I mean by that is what is the first term. And I'm going to write down A1 underneath what it starts with. We're going to use those two things to describe the pattern. Describe the pattern. It's subtracting by 4, and it starts with number 15. That way we can figure out all the numbers from these two things. Now the next question. Then find the next two terms. Do you know what the next number is going to be here? If you do, tell the person you're sitting next to, please. Okay. I'm going to call on somebody who knows I'm going to call on them. Cian, what is the next number?
-5.
Perfect. And somebody else who's not expecting me to call on her, but I'm going to. Presley, what's the next number? -9. Do you agree? And this is how you answer number 1. You describe the pattern and you just say, what's happening? It's subtracting by 4 and it started with 15. And then the next two numbers were -5 and -9. These are the next two numbers. Does that make sense now? She's got it. Doesn't seem like there's any other questions. So here's what I want you to know now that we have that. What is an arithmetic sequence? Let's write down what an arithmetic sequence is. And I say arithmetic, but just like you can pronounce tomato or tomato, it doesn't matter how you say it. It means the same thing. Tomato or tomato means a tomato. Okay? Arithmetic or arithmetic is the same thing. If you're reading this and you see arithmetic, that's fine. You can call it an arithmetic sequence if you want to. Tomato, tomato, potato, potato. Doesn't matter. Arithmetic sequence. That's how I was taught it. I've kind of liked it, so I've said it that way ever since. What is an arithmetic sequence? It's a linear sequence that adds or subtracts the same amount to get to the next number. An arithmetic sequence is a linear sequence that adds or subtracts the same amount to get to the next number. You are going to have to tell on this worksheet and on future problems whether something is an arithmetic sequence or not. If you look at a pattern, let's go back to the one that's up here. Am I subtracting the same amount every time? What did we subtract? 4. We subtracted 4. We subtracted 4. We subtracted 4. If it subtracts the same amount every time, then guess what? It is arithmetic. If it multiplies by 4 and multiplies by 4, it is no longer arithmetic. It is something we will learn in a later unit called geometric. But if you add 4 and you subtract 4 and you add 4 and you subtract 4, it is no longer arithmetic because you're adding and subtracting different amounts. It needs to add or subtract the same amount. As a part of arithmetic sequences, you need to know what A1 is. A1, and I'm going to write it like this. Big A, parenthesis 1. And that's going to represent your first term is equal to the first term. A1, A parenthesis 1 is equal to the first term. When I ask you to write what is A1, you're going to tell me what the first term is. For example, earlier, remember how we looked at this sequence? What does it start with? You told me it started with 15. Guess what? A1 is equal to 15. That's what that is. And most of the time we're going to use a capital A. You could use the lowercase a, it doesn't matter. But I believe our textbook and homework and quizzes have capital letters, so I'm going to show you the same way that we do. A1 is the first term. And I could use A2 as the second term, and A3 as the third term, and A4 as the fourth term, and so on. That's what that means. It's going to represent that term number. For example, I'll go back up here under questions. Earlier, A1 is the first term, right? 15. If I'm using this sequence here and I say A2 equals, that means you should know what the value of the second term is. If I have A2, not the first term, the second term's value is 11. That's the answer. That's what A2 means. Okay, so now here's checking for understanding. A3 equals blank. Tell the person you're sitting next to what A of 3 is for this example sequence.
7.
If you said 7, which I overheard every single person of you said 7, you are correct. Good job. Simple, right? So now we know the first term. We need to know what D stands for. It's a little d. Let me recenter this so you could see it. D is going to stand for the common difference. D stands for the common difference. The difference between the numbers that has to be the same in an arithmetic sequence. It is the amount that is added or subtracted in an arithmetic sequence. The common difference, since this is a definition, I'm going to underline it. Later on, you can come back and highlight it when you're going over your notes again, when you're doing some R&R. The amount that is added or subtracted in the arithmetic sequence. If I go back to this pattern and I want to know what D is, I'm going to do it off to the left right here. What did happen from 15 to 11? You said we subtracted by 4. What that means is that the common difference, since this is going down, our common difference is -4. If it was going up, if it was adding, we would make this a positive. But because we're subtracting 4 and subtracting 4 and subtracting 4 and subtracting 4, our common difference is -4. And if you have these two pieces, the A1 and the D, we can write a rule for an arithmetic sequence. There's a formula for it. Let me show you what the formula looks like so you can write it down. I'm going to put it right underneath arithmetic sequence. It looks like this. A parentheses N equals A parenthesis of 1 plus N minus 1 in parentheses times in parentheses D. I'm going to highlight this one. I have a highlighter. I need this to stand out a little bit so you can see it because you're going to use it often. A of n is equal to A of 1 plus n minus 1 times D. This is how we're going to write our arithmetic sequence formulas. What you have to know are two things. You have to know the A of 1, and I'm going to underline it in a different color. I'm going to underline it in pink. I know that doesn't look very pink up there, but it is. And I'm going to underline the D. I think it's because I have pink and yellow on top of each other, and I think that makes orange. Red and yellow make orange, so that kind of makes sense to me. I have to replace these two things. I only replace these two things when I'm writing an arithmetic sequence rule. And so I need to write that down off to the side. Over here. Only, let me recenter that. Right even with this, I'm writing only replace the A1 and the D when writing the rule. A little star. Only replace the A1 and the D when writing the rule. this is the way that we're going to write it. For example, so earlier I have this. I'm now going to use this to write the rule for this. Okay? What I have to do is I write everything from left to right except I replace this piece and I replace this piece, but everything stays the same. For example, I would write A of n, that doesn't change. What's next? Equals. And if I'm looking at number 1, and I said I need to replace what's here, do you know what A of 1 is for this example?
15.
So we write 15. I replace it. Plus. What comes next? In parentheses. And minus 1. Don't change it. It's not underlined. We leave it the same. Do you know what the D is for that example?
-4.
In parentheses, -4. This is the rule. That is how you write the rule. You only need to know 2 things. You only need to know what is A of 1. You plug it in. You need to know what the D is. You plug it in. I'm hoping that's not too hard. What this means is we can now figure out what any term number is. An example of what you are going to have to do is something like this. Find the 4th, 6th, and 13th terms. Let me move that up because that's a little low on the board. Find the 4th, the 6th, and the 13th term. And that will look like problems 15 through 20. So I'm going to put 15 through 20 right here in a bubble. That way, when you're looking at your notes and doing your worksheet, you'll know which ones line up. What this is asking you to do is it's asking you to find A of 4. When you have the 4th term, to plug in 4 into the formula and figure out what it is. If I want to know what the 4th term is, what I have to do is take your rule and then you plug in 4 in for n. Plus 4 minus 1 times -4. And I'll let you decide how you want to do it from here. You can either break out your calculator or you can do this by hand. It's up to you. But if you are not good with your order of operations or negatives and positives, I'm going to tell you use the calculator. Okay? Order of operations, parentheses, 4 minus 1 is 3 times -4 is -12. 15 minus 12 is 3. If you want to double check yourself, here's the 15 plus parenthesis 4 minus 1, end of parenthesis times -4. I think it'll let me do this. Riley, you all right?
Yeah.
Okay, shh, you're distracting Mark. Okay, and myself. So what did we find? We found the 4th term's value. Can we find the 6th term's value? Okay, A of 6 equals. If I want to find the 6th term's value, I take my rule, I write everything the same except instead of n, I plug in the number 6. Kyler, what am I going to write for a of 6? Tell me what I write down, please.
15.
Thank you. Thank you.
6.
Thank you.
6
Yes.
minus 1.
Yes.
Negative 26. Everybody watch.
Perfect. That's how you find the 6th term. What she just did is what you need to do when you're finding the 6th term. You plug in 6 in for n. You want me to use the calculator, or do you want to do this in your head? Okay, if you are a calculator person, since you've already had this typed in here, you can just go over and delete the 4 and put in 6. Five times that's negative 20. Negative 20 and 15 is negative 5. That works. And the last one, a of 13. So here's our 6th term. Here's our 4th term. Let's do a of 13 equals. Michaela, what am I going to write to find the 13th term? Do you know?
15 plus.
Good. Good.
Parentheses.
Good.
13 minus 1. And then parentheses. Negative 4.
In parentheses, because we're multiplying by it. Perfect. Absolutely. I've already typed all that in there. I'm just going to change the 6 to a 13. That's what's nice about these calculators when you don't press clear. Those of you who love to press clear 10 times, you don't need to do that. Just leave it there and you can make a small change on your calculator and you can figure out what the 13th term is easily. Which is? That's what I got. One other thing I need to mention. The formula that we are using, this rule or equation, there's a name for it. It's called, I know this is weird, it's called the explicit form. This is called the explicit form. And I was thinking to myself, I think these kids have never heard this word before, other than when they hear the word explicit, they might think explicit lyrics, but that's not what this means. This means it's the form that's used to find any value. What's nice about the explicit form is I can find the 100th term, or I can find the 1st term, or I can find the 10th term, or I can find the 1,000,000th term. Kind of nice. Almost there, almost there. We have to know if that's the explicit form, there's got to be another form as well. There's something called the recursive form as well. Let's write out what the recursive formula is. Oh, it's too low on the board. Almost at the bottom of my notes. Recursive formula. There's an explicit form and there's a recursive form. They're very similar to each other, except the recursive formula is longer. Here's the recursive formula. A of 1 equals blank. And I'm going to put a little blank spot right here. Then it comes semicolon. Then comes A of n equals A parenthesis n minus 1 end of parenthesis plus D. I'm going to highlight this one in yellow as well. Because we use both of these two things all the time. And the only things we have to replace, just like before, is this thing here in orange and this thing here in orange. I only replace those two things. I don't have to replace anything else. What's different about the recursive formula is, like, why is there this one and why is there explicit? Explicit, you can find any value anywhere along the line. The recursive formula is the one that you're using right now. The recursive formula is the formula that is, this is based off the preceding number. I know this is going to be a little bit hard, but I'm going to do my best to explain what this means. It's based off the preceding number. What you did at the very, very beginning of this set of notes, you knew what the number was going to be, the next number, right? How did you know the next number was going to be 3? You just had to look and see that you were subtracting 4. So what you're doing is taking this number, and to find the next number, you subtract 4 from it. That's what this formula does. If you know the first number, then to find the next number, which is, let's call it the second number, all we have to do is to take the number before the second number, the first number, plus D, whatever that is. It's a formula based off of the preceding number. Let me show you how we write this formula down for that first example. I write everything the same except for what's in orange. I write A of 1 equals. But I have to replace the orange piece. Eric, in that first example, do you know what A of 1 was? The very, very top? Yep, it was 15. So you would write it like that. Semicolon. And you're going to write everything else the same. Adeline, what do I write next? A parentheses N. Good. Gracie, what do I write next?
Equals A parentheses N minus 1.
Perfect. Cade, what are we going to write next? Plus, wait, what is that though? We got to replace it because it's underlined. We have to replace it with its number counterpart. What is the number for D? Negative 4. Do I have to put plus a negative 4? No. You can just put minus 4 and that will be fine. If you want to put plus a negative 4, that is fine as well. But we're subtracting 4 from the preceding number. And this is your formula. It's easy. So I'll do one last example, and then you'll be ready. I'm turning this over. This will look like number 24. This will look like 24. 1.5. Comma, 2.1, comma, 2.7, comma, 3.3, comma, ellipses. 3 dots in a row is ellipses, and it means the pattern continues in mathematics. And your directions will say, write an explicit formula and a recursive formula for this sequence. Explicit. You got to know two things. I hope you know what the two things are. What is one of the two things you have to know for the sequence? Let me call on somebody who's not ready. God, I don't know why I'm blinking on your name again. Connor is ready. Connor, what is one of the two things I need to know?
The starting number.
Good. What is that called? We have it on the other side of our notes if you need to look. Look. The starting number. What is that called, or what do we use for that? What is it?
The first term.
Good. What should I write down? Tell me what you want me to write down first. You're on the right track, but it's not how I want it. You're close. When you said the first term, I like it, but I have something on this front side that I need to write down. And you said first term, so here it is. This is the symbol I need to write down, Connor. Let's go back over here. What do I need to know? Go back into Connor Fritsch. Yes. And what is A of 1 in this example, Connor? It's 1.5. Just like that. You don't do anything else. A of 1, that's what this means. The first term's value is equal to 1.5. We don't do anything else other than that for the A of 1. Okay? I'm going to leave that right there because I'm not going to touch it yet. There is a second thing I need to know. Cece, do you know what the second thing is that you need to know?
You have to find what it's going to be outside.
Yes, there's a name for it. If you don't know, look back at your notes. Hang on. You're absolutely right. I just want you to use the words. What is it? The common difference. Good. There's a symbol for it. A very, very short symbol. What is the symbol? D. She told us that we need to know what D is. Now Trinity, I think, knows what the D is. What is the D, Trinity? You don't know that. You don't know what it is. What do you think? What? Say it again. 0.6. I'm going to put 0.6. Do we agree?
Yes.
Good. When you know these two things, now you can write the explicit formula. I'm hoping you know how to do it. Let's see. Ah, man, I've called on lots of people. Let's go to Jason. I haven't called on you. Jason, what am I going to do to write the explicit formula now that I know these two things?
I need to put in like n after the parentheses.
Thank you.
Okay, parentheses. Then you need to put an equal sign.
Thank you.
Then the 1.5, which is the a parentheses 1.
Good.
Plus parentheses n minus 1. And then parentheses n plus 0.6.
You don't have to put plus because we're multiplying by it. But if it was, I guess you can do that. I'm not going to put a plus sign there because I don't want you to think you're adding. I'm just going to put 0.6. I like it. If you do not know how he did that, all he's doing is going over here and he's using the explicit formula. Did I not write explicit form? Oh, let me just put explicit right here. Explicit. That'll help. Here's the explicit formula, and all he's doing is writing everything the same except what's underlined. He replaced A of 1 and he replaced the D. That's what he's doing. We've answered half the question. Write an explicit formula. Here you go. And a recursive formula. Recursive. And it's the same thing, except instead of using this and replacing, we have to use this and replace stuff. So now I'm going to ask somebody else who I haven't called on yet today. Katie Lynn. Is that right? Yeah, there we go. What do I write? If you know what it is, sure.
Okay, 1.5.
Oh, nope, that's not what we're going to write. You're close. Chris, what would you put for the recursive formula? Any ideas? No. Colby, what would you write? This will be the last one. If not, I reteach. Colby's confused. Okay, let me go back to this side for Katie and for Chris and for anybody else who doesn't know. When I'm writing the recursive formula from left to right, do I change this? No. I only replace what's underneath, underlined in orange. That's the only thing I replace, but I write everything else down the same. Turn it back over. Katie, what do I write? Stop, Blake. What do I write after the A? Perfect, stop. Chris, what do I write after the A? Good. Colby, what do I write after the A? Wonderful. It's like they understood what I just said. I like that. That's important to me. And now, I hope you know what comes next. Kyler's screaming it. It's killing her. What is it, Kyler? Yes, it is right. Yes, absolutely. And then, Michaela Knowles, what comes next? Semicolon, good. Melina, what comes next? Good. Christina, what comes next? I didn't hear you say it again. So close. There's something in between. Something small that you did not see. Equals. Thank you. Now tell me what you said. Because that was right, but you forgot that equal sign. Good. And then there's one more thing that we need to put here. And we're going to replace it with the numbers this time. Presley. Perfect. If you understood these notes, you are going to do just fine on worksheet 2.7.